Hey, good morning, everyone. Thank you so much for joining India Azure Community Conference 2020. I'm Ilyas. I work as an IoT evangelist at ABP, and I'm a Microsoft Azure MVP and one of the organizers of this beautiful conference. In this session, I'm going to walk you through how we could use Kubernetes API to deploy Azure IoT Edge as well as its modules. I'm sure throughout this conference you must have observed a lot of Kubernetes talks being presented, ranging from how we could build microservices and how we could deploy them on AKS clusters and how we could secure them and so on. So in this case, we're going to look at more of IoT Edge scenarios and how Kubernetes can help us running these edges on Kubernetes. So before we get started with the actual content, let me quickly walk you through a bit of agenda. So we're going to start the session with a reference architecture. If you're familiar with Azure IoT Edge and its various software offerings to build IoT solutions, this must be very familiar. And then we'll go through a bit of device connectivity patterns, because this being Edge scenario, it's very relevant that we get ourselves familiar with device connectivity patterns. And then I'll quickly introduce you to the Azure IoT Edge and the various deployment options available for us. And then we'll go through a quick introduction of IoT Edge on Kubernetes, and we'll also go through the various business scenarios and customer scenarios, why it might be relevant for us to go this route. And then we'll go through a deployment flow, and then we'll end the session with a demo. Like I said, so if you've been working on IoT use cases, this must be very familiar for you. Likewise, if you're trying to learn IoT, Azure IoT, you might have come across several of this flows and reference architecture. On a very high level, IoT solutions are basically about three things, right? So, connecting things, collecting a lot of data, and thereby collect insights from those data. And then with the data, we can drive actions, right? So if you apply this analogy on top of any IoT scenarios, just think of doing a predictive maintenance for machineries. Just think of robots, right? So the robots could be used on very important work in factories. Just think of painting robots, right? So these painting robots are employed to paint cars. Now, if the robots are down for a day, then it's a loss of business for the site or the factory operator. So it's very important for us to make sure the robots are doing well in terms of the health, and if there's any problem, it is important that we predict those robot health and fix them well in advance. And with IoT, we could do this very well by connecting those robots and collect the health information. And with the health information, we'll be able to predict how the robots are performing now and how they may perform in the future, right? So that's all about IoT. Now, with things on the left, we have different ways in which we can connect these robots or devices, for that matter, to IoT backend solutions that we may build. And then the first thing that they would hit on the cloud side is a cloud gateway. So in this case, it's IoT Hub. So once the data is received in the IoT Hub, the data can then be using Stream Analytics. We could do a live reporting or live analysis on top of this data. So that's like a hard data processing. Or we could use data processing or data transformation a logic, where we could use a function app to transform the data, because the device is going to be variety of there's going to be variety of devices, and the format of the data could be largely different. So using the data transformation, we might be able to transform all those different types of data into a singular format that we could further store, analyze, or we could do cold path analysis or batch analysis, right? So for all that, we could use the different services that Azure offers to do to build such an application. And of course, Azure AD could be used to to secure all the different components that we may use to build this application. And you could also observe that we have Microsoft machine learning tools and technologies that could be used to predict any kind of data. So in this case, it's mostly about telemetry data. So Azure machine learning models can help us to predict those data as well. So that's a reference architecture. So now let's move ahead and look at a lot of other services that can be used to build IoT solutions as well, right? Just like web applications, IoT solutions not different, right? So it depends on the business cases and scenarios that we are working on that defines the choice of components that we pick to build IoT backend. Right. So on the left, you have these IoT devices that you're going to see in the next slides, but you could see a different set of services that could help us to build commercial enterprise grade IoT solutions. On the right, you have different visualization services like Power BI and Power Apps that could help us to build applications, as well as custom web applications and mobile devices. So these are the various services that one could use to build IoT solutions. Looking at the connectivity patterns or the device patterns, we have different variety of ways in which we could connect these, build these devices, right? The first one is IoT device SDK. So Microsoft offers different device SDKs for different languages, Node, C#, Java, Python, and various other languages for us to build device firmware, right? Again, it depends on the use case that we are handling. For example, if we are building a device that can send some data and transmit those data to the backend using a GSM or Wi-Fi, and if the device can hold some amount of compute and memory to process those data, we could use IoT device SDK to build such devices. The second type of devices are mostly devices that cannot have internet connectivity, right? So just think of devices that would sit on a factory floor or a site or places where you can't simply imagine internet connectivity, or it is a rugged device that cannot that cannot be processing data, or it cannot hold any compute or memory. So these are basically devices that can only transfer its health data using electromechanical or electrical signals, right? So such devices can be connected using Azure IoT Edge. IoT Edge is basically a software offering that basically helps us to run on a device, or it could be like, just imagine a Raspberry device, or there are a lot of industrialized servers or industrialized PCs that's specialized on running such applications in a factory site, right? So Azure IoT Edge is an open source software that can be either installed on a Windows or Linux box. So the fundamental execution model is Docker containers. So we could build application that can be Docker containerized, and then the Azure IoT Edge can simply run and orchestrate these models, and we'll be able to connect through all these models and route the messages to cloud, right? So that's a IoT Edge. And as you could see, you would be able to run or build and run a different set of modules, and one being a protocol adaptation, right? So like I said, these devices doesn't talk HTTP because these are a specific industry focused or industry built application which talks very legacy protocols. Now we could build a C# or Java application that can do the protocol transformation, right? So as well as you could run stream analytics job or machine learning Docker container on these devices. So that's Azure IoT Edge. Now let's quickly look at how this would look in practical, right? So here are the robots that I talked about. These devices are not able to, or they are not allowed to connect to internet directly. Instead, we have an IoT Edge device, right? Just think of this as a server which has IoT Edge runtime, which is pre-installed, and these are the modules. These are basically C# or Java modules that I have built, and these modules connects to these robots, collect the data, and do the protocol transformation, because these devices doesn't talk HTTP, and hence I will not be able to directly send the data to cloud. And instead, I have introduced this IoT Edge device which collects the data and then process it, transforms it, filters it, and then I could also build a machine learning model to apply some machine learning models on top of the data before I send it to the cloud, right? So that's exactly Azure IoT Edge. So let's quickly look at a bit more in detail of what this IoT Edge device looks like and what are the various components that it holds. So from the bottom up, these are the various devices that could host our IoT Edge software, right? So these are few of the options that I have kept it here, but you could go to Azure Device Catalog, which is a website by Microsoft that lists all the compatible hardwares with Azure IoT Edge software. So fundamentally, so Azure IoT Edge provides all these components, right from hardware-based root of trust, and then security manager to securely boot the hardware as well as the operating system that runs the IoT Edge, and device provisioning service, right? So device provisioning service is a key component to provision thousands of devices without any manual intervention, right? With the help of X509 certificates. Again, that's not the topic of this session, but device provisioning greatly helps us to simplify the device provisioning into the cloud backend. And then Edge runtime. This is the guy which takes the responsibility of spinning up these different containers that holds our software applications inside it, right? So these are submitted as a deployment from the cloud, so that the IoT Edge looks at those definition or deployment and deploys the way we want to run them on the Azure IoT Edge. Again, we looked at the modules. These are container-based workloads. It could be a custom-built application that we built for solving some of the specific purposes, or it could also be pre-built applications, right? For example, Azure Functions, stream analytics, or machine learning models, and so on. Again, the Azure IoT Edge can be deployed on both Linux as well as Windows, and basically runs on top of Docker compatible container system. So in a nutshell, this is all about Azure Edge. Let's quickly look at the use cases and scenarios why this is important for businesses to run Azure IoT using a Kubernetes cluster. The first and foremost is it's yet another option to host and deploy Azure IoT Edge and its modules, right? Because more and more customers and enterprises are looking at AKS or Kubernetes as an option to build and deploy their applications. Now, when a site or when a factory already has a Kubernetes cluster in place, it's a natural choice for them to also deploy IoTEdge in the same infrastructure. When they choose to do that, it becomes a one-stop shop for deploying their applications, web applications, or APIs in addition to Azure IoT Edge. And same goes for this reason of uniform infrastructure solution across cloud and edge, because Kubernetes has become the de facto options for building a variety of different applications. Now, Edge is becoming the next set of new applications that can also be deployed on Kubernetes. And hence, Kubernetes is one infrastructure layer that can host a variety of different applications. The next reason that I can think of is, the edge devices are getting powerful, right? So now there are beefy machines that are coming in the reasonable cost, and hence Kubernetes is a choice for us to deploy them on those devices. And the second reason is Kubernetes is also becoming smaller. Now with K9s or micro K Kubernetes are the same large Kubernetes clusters capability, but in a minuscule size, probably less than 50 MB of size. So these are the reason why now enterprises are looking at hosting Kubernetes cluster right on the edge. Right? And then we also talked about the single deployment model, and especially if you are building IoT solutions, not just edge on Kubernetes, but think about a different set of devices. There could be IoT devices that runs on handheld devices, as well as devices that's connected behind Azure IoT Edge, as well as IoT Edge on Kubernetes. So irrespective of the devices and the models, now we could use IoT Hub's own deployment manifest to deploy these modules on top of them. And finally, all the good reasons why Kubernetes is so popular, for example, scalability and high availability and security, we could extend all those capabilities for deploying Azure IoT Edge as well as it's for modules. So now that we understand how Kubernetes can be deployed on Kubernetes, as well as the business scenarios and why customers are looking at running Edge on Kubernetes, let's quickly go through how is it different from a typical Edge deployment on a server or a hardware box, versus deploying this on a Kubernetes. So the fundamental difference between running Azure IoT Edge on a server or single node, a single device versus Kubernetes cluster is in a typical server deployment, the IoT Edge daemon looks at the manifest and then deploys them, each one of the modules, as containers. Whereas in Kubernetes, these are converted into Kubernetes own structures, that's deployment and parts, right? And this is done by the daemon. So the IoT Edge daemon is basically a custom resource definition. In the Kubernetes world, CRDs is basically a custom resource API that helps us to run the APIs in the way that we want. So the first thing here is we need a Kubernetes cluster. Right. So in my demo, I have built, I've just got a AKS cluster, and I'm going to walk you through all that we are looking at in the deployment flow. So I have a Kubernetes cluster, which is version 1.12 plus. And then we have a namespace. So the namespace is a logical segregation or a virtual cluster within the public cluster, right? So in the way you see this is, if you have multiple edges to be deployed, you would create multiple namespaces. So this is your virtual isolation within your physical cluster. So if you want to run more than one edge, so you would create multiple namespaces and then deploy this to have a virtual isolation or virtual a setup for your edge to be running. And then we would install IoTEdge daemon using Helm chart. So Helm is basically a package manager for Kubernetes. So we're going to use that to deploy the Edge daemon as well as the Edge agent and so on. Right, so it's just one command using which we could deploy all the necessary agents and Edge hub and Edge daemon and so on. So once the custom CRD is deployed, we could then set up a device and then submit the manifest. And once the manifest is in place, the Edge agent component deployed by the CRD is going to make a handshake with IoT hub modules and create the module identities and twins that are necessary for deploying the modules. So once the identities are created, the Edge agent is going to run the modules as different pods as per the Kubernetes APIs. And once everything is in place, the modules can then connect the devices and then collect the data and directly talk to IoT hub and publish the data. All right, so with that, let's quickly look at a demonstration to understand what we just learned in the presentation. All right, so before we get into the actual demo, let's quickly look at the prerequisites for us to have the activity done. So first and foremost, we need to have Kubernetes cluster installed on a server box so that we could deploy the Edge workload, and preferably version 1.12 and above. And luckily, I use Azure portal to stand up a K8s cluster, right? I mean, if you're getting started, it's better that you do on your desktop, or if you have a Raspberry Pi, you could also install K9s or micro Kubernetes to get started with this. But as it was easy for me to stand up a K8s cluster and do this activity. So whatever is easier for you, you could simply do that. And then you need to install Helm chart. So Helm is basically a NuGet for, just like NuGet for .NET or NPM for Node. Helm is basically a package manager to automate certain tasks with Kubernetes. So this could greatly simplify the way we deploy workloads on Kubernetes. And kubectl. Kubectl helps us to work with the Kubernetes API, like deploying applications or checking the pods and so on. And then VS Code with IoT extension plus Kubernetes extension. This greatly simplifies all that we have to do to deploy IoTEdge and its modules on Kubernetes cluster. All right. Let me now open the VS Code and then show you how we can get started with this. Why did I open Bing? VS Code. So this goes to my secondary monitor. Let me pull that to here. Okay, so let's get started with the very first activity of not this one. I need to open the terminal. So let's get started by verifying whether we have all the prerequisites in place. So first let's go into kubectl version to check kubectl. Yes, I have kubectl installed, and then let me also do Helm version to check if Helm is also in place. Looks like it is good. And let me also show you the Kubernetes extensions. I'm a big fan of this VS Code extension, just like you. So I go ahead and install all these extensions like crazy. But in this case, I needed Kubernetes extension simply because I'm not a command person, and this Kubernetes extension greatly simplifies what we can do with the cluster. All right, so let me quickly check if there's any namespace that I can deploy. Looks like this only the default namespaces. So let's go ahead and create a namespace. Kubectl create namespace. Let's call this as Edge 1 because this is my first Edge device. So let me do that. All right, so once we have namespace created, let's see if we can see that. Yeah, so right here, and let's use that namespace for deploying our Edge devices on it. Right, so now Edge 1 is made the default namespace that I can work with. The next thing that I can do is install the Edge daemons and Edge agent containers, and for that we have a simple Helm chart command using which we could deploy that. All right, so if you go through the command, we're basically saying Helm install and where to find the custom CRD files, the name of the custom CRD files, and then which file to install, right? So that's all we are saying. Let's install the necessary CRD files so that the Edge daemon and Edge agent, Edge hub, all that will be installed. All right, it is going and getting the CRDs, and then it has installed the Edge CRD in place. Now we are almost ready to set up our first device on this namespace. And before we do that, let's say Helm list to see the CRD we just installed, and that is Edge CRD. And he is responsible to bring up the Edge agent and Edge hub and all that is needed for setting up the modules that we are going to push. So once that is done, then we could deploy our first device. So this is basically is a step that we do configuration, right? So let me just copy paste my command that I have in a notepad to simplify thing, and let me walk you through what we are trying to do here. So again, we are saying Helm install, from where we could get the CRD file. So in this case, it is stored in Edge Kubernetes blob core windows.net staging, and name of the Edge. So here is where I'm going to define the name or give the name of the device that I'm going to create on Azure portal, and for that I need to go to Azure portal itself. So let me open a browser and go to portal.azure.com because I need a device to be created on my IoTEdge. Again, I have created this IoT hub already to save some time. So it's going to be in pretty soon. So as soon as we have the portal up, let's go to this IoTEdge because this is what I'm using to show the demonstration. Okay, so here you see IoT devices and IoTEdge, and in this case we are doing IoTEdge. So let's go here. All right, so if there are any devices, maybe we could remove them and create a brand new device. So I was playing with a few scenarios. I've created all of these. Well, let me clean this up so we can start from scratch again. So it should be quick. All right, so all those old edges have gone. Now let's start with a new edge. So let me name this as edge 1, and we need not worry about these authentication types. So as this is demo, we could very well live with symmetry key, but then don't use it for the production scenario. So always choose to go with X509. So that's a better security type for production workloads. And then you could leave the rest as is and click on save to create, to have a first device created. So once the device is created, we need to grab the connection string so that we could configure our device on Kubernetes cluster. Right, so here we have the primary and secondary connection string. So let's go ahead and grab the primary connection string and head over to the VS Code terminal, and let's change this to edge 1, and this is going to be deployed in the namespace edge 1 as well. And then I have to update the connection string so that it would provision the right device on this namespace named edge 1. All right, all looks good. Let's go and execute it so that we have our device deployed. It's going to take a while because it's going to look at the CRD and then go get the device related settings and then set up the IoT Edge itself on this namespace. It should be up in a moment. All right, so we have the Edge configured properly. So we could go back to the portal and check if so in a moment it should be up and should give us the specified in deployment. All right, so while that is happening, let's start deploying a module. All right, so here we could deploy our custom module built by us, or deploy a module from a marketplace, right? So just like Azure Marketplace, we have Edge module marketplace where you could find modules from different players in the market, as well as a simulated temperature sensor. That's one of my favorite, that helps us to get started quickly by deploying a module into our Edge. So I'm choosing to run this particular module, and then you could leave the rest if you want to send the usage data, because this is basically a helper module, and Microsoft wants to improve their products and service by collecting some of the logs. So it is up to you whether you want to leave this or not. And let's go ahead and create, and here you could see the deployment manifest, right? So if you go to the top, we have Edge agent and the desired properties, the simulated temperature sensor, and the Docker container which contains the code, as well as the Edge agent property, the Edge agent Docker container, and then various options when the Docker container gets created, and the routing, right? So at this moment we just got one module, and all the messages from that module goes to upstream. So the upstream is then connected to IoT Hub, and IoT Hub would receive the data, and then some send interval frequency, right? So all looks good. Now we can click on create to deploy this manifest. All right, so now Edge agent, Edge Hub is going to come up, and then now we have deployed simulated temperature sensor. Right. So in a moment, all these would show up in our Kubernetes cluster. So let's go back and look at our VS Code and see if the deployments are coming up here on the workloads. So we could use kubectl get pods, and here we go. So we have the Edge agent, Edge hub, and the daemon. All of them are running as pods instead of containers. Of course, this is containers inside the Kubernetes cluster, but the important thing to note here is Kubernetes have taken the deployment that we usually go with, and then it has the CRDs that we deployed have converted those deployment into pods as per Kubernetes. Right, so now these guys are working. Now let's go ahead and look at the logs, because these this particular module is simulating some data. Now let's look at the pods, and this is where the Kubernetes extensions come very, very handy. So if you say follow logs, it would now, okay, I just want to connect directly to the log of that temperature, and here you could see the messages are getting sent from this module. Right, now let's quickly look at how we could see the same in IoT Hub. And for that, we have Azure AZ command. Let me open this one. Terminal, not the terminal, the palette window, and look for options here. That is start monitoring built-in event endpoint. Hopefully this should get all the devices that are received by IoT Hub. Very good. Now we see the same data that's pumped by the simulator module to our IoT Hub. Nice and simple. Great. Hope this gives you a brief idea about how you could deploy IoTEdge that you are very familiar in deploying against a single node server now on AKS cluster. With that, let me quickly show some of the references that you could further go and read about in Azure IoT Edge on AKS. But please note, Azure IoT Edge on Kubernetes is just on preview, and the team is still developing, right? So, start using this service, and if you have any feedback or suggestions or comments, please go to the respective GitHub page and submit your PR if you want to contribute or raise issues or raise questions. All right. So with that, let me open some of the references that you could go and read more about this service. So let me quickly search, go back to the PPT and then walk you from there. All right, so for further references, you could go to IoTEdge documentation, and you could go to Channel 9 video, the Internet of Things show by the IoT team. That's very helpful. And here is where the IoTEdge documentations are. Let me quickly open that and then show you. And I personally found this one interesting. So let me open here. So here is where the code base of IoTEdge is. So if you are interested to contribute or raise a issue or submit a bug, you could go to this page. And personally, I found this lab is very interesting because these are hands-on labs with a very step-by-step approach. Module by module approach. You could start with introduction and then go and play with setting up the lab environment and connecting devices and going scale. And it's an elaborate step-by-step learning approach for you to get started. And that's it. And before I close, let me open and show you the microsite built by the IoTEdge team. I found really useful and easy to follow along, and in fact the demo that I presented is actually from this, and I've just barely scratched the surface. In fact I just executed hello world and few more references from this docs, but I request you to go through the rest of the scenarios presented in this web page. That'd be highly useful for you if you're interested in more digging deep into running IoTEdge on Kubernetes cluster. All right. So with that, we are end of the session. I would like to thank all the sponsors, including Microsoft, GitHub, and Elastic, in helping us to run the conference. And I would like to specifically thank all the communities, women communities, as well as Azure Tech communities who have come together to put together this wonderful show. Finally, thank you so much for joining this conference. And if you have any question, please feel free to tweet me on this Twitter handle, or you could use the chat window to ask any questions. Again, thank you so much for joining me and with this session as well as the rest of the session. I hope you will find the rest of the conference very useful as well. Thank you so much.